Hello, my name is Nadine, and this video is to present the homework from software testing in Chungbuk National University in the year of 2025 spring semester. To give a brief introduction of this homework, it was to find several faults from the given code using sanitizer. The code that was given is a program called URL parser.c, which receives the list of URL as inputs and returns the information of the given URL. So I found 3 different types of faults in this code, and I will explain using slides and with the terminal that's actually operating, with the program that's actually operating. So the first bug I found is a segmentation fault with the input column. And let me actually execute the run script. So here I built a program with clang and fsanitize address option. And this is the program that induces a segmentation fault. So here I gave, well, it's not really given, the input is not really seen here, but the colon was given as an input. And here, if we check out the messages, it says it was trying to use a null pointer, the unknown address null, in the line 51 when it's using the function string length. And yeah, let me explain more. So the line 51 uses string length token, and let's actually check out the code. So in line 51, as you can see here, it's using token as in the string length, but the token here becomes null in the line 50 when it uses string token with the input colon. So the null point dereference occurs, and that's why we can see the segmentation fault here. So to fix this, we have to verify the token is not null. So in order to fix this code, I added if token is null, then we return to the main. So let me show you the fixed code. So here I added this. Well, this one's like a final version of fixed, so we have one more line there, but I will explain that later. So basically, I fixed this code with returning 1 after checking if the token is null. And the second fault I found is a memory leak. It's actually that only occurs after the fixed, after it gets fixed from the previous slide. So let's actually run the script once again. So here with the program mleak, it actually outputs that outputs like in a original way, like in an ordinal way. but it says it detected memory leaks. Actually, in two different codes, locations of codes. So one from the line 140 and the other from the line 34, where both uses malloc. So let's check out the code once again. I actually have the code here. It's the fixed version from the segmentation fault because it can only occur after the, like I said, it only occurs after the fixing. So here it uses malloc and it's allocated, the memory is allocated, but it never gets freed. And let's actually go to the parse URL function where it returns error. So this so the error occurs because it never frees once it receives the error code from line 142. It just prints this error message and continues the rest of the line, which is why the free parsed URL from line 150 never gets executed. And that's the reason of memory leak. So to fix this again, there are actually two options. So first is to free after checking the parsed URL is not after it receives error code from the function. And the other is to this is to use a very basic free function. But if we want to use the user-defined function free parsed URL, we actually have to make one more fix in the line 140. We have to change malloc to calloc so that the rest of the allocated variables in the struct URL parser URLT is null, is like initialized. Yeah. And let's see another allocation. So this one's again, oops. So this one's again the same. It never gets freed after it is allocated. So we also have to fix this by free before it gets before the program terminates. So we add if local URL, if your local URL is allocated, we just free them before we return to the main function. So it's actually like, this is an exceptional case. This was 45. Okay. So here, parsed URL, so here, yes, in line 34, local URL is memory allocated, but then when it returns to 1, this is actually the fixed version. So when the token is null, it returns to 1. I mean, it returns 1, but we have to free the allocated local URL variable before we return. So by simply adding free before we return, we can fix this. And the last error is buffer overrun. And the input I used is this whole URL, but the key point here is to have this port number and the slash string. let's check out the run script. So here, this is the overrun program resulting in error, the heap buffer overflow. So we actually have two, but we can only see one here. So in line 100, parse URL uses string cat, but this actually tries to write size 6, which means it's, yeah, overrunning. So, and here they are actually telling us that in which part the memory is allocated. So in line 98, this is the original memory allocated, but then here when it tries to write, it's using more than it's allocated. Yeah, so this is the part. So if we see here, it's reallocated, and it actually adds slash. It copies the slash and adds token next to the slash, but the size of reallocated is string length of token plus 1, which is not enough because we added slash here in the line 99. So we need 2 more spaces actually, one for slash and the other for the null pointer. So let's see. Can actually, oops. But even we fixed with adding one more space, one more size for reallocation, we again see the buffer overrun. Here now, it's trying to read size 8, and it's actually making error when it tries to print. So let's check out the line 102 when it allocates the memory. So here it allocates the memory now after it, the path from the struct. It's actually specifying the size here with string n copy, but the specified size is again not enough. So we need one more space, one more size, one more byte for a null pointer. And let's actually, I do have a fixed version of both. And here, so I added one more size for string and copy. And let's check out all the fixed version. So with the fixed version, you can see here with the input column, it's now not giving messages of segmentation fault or memory leak. And again, with the input URL, like the one with the port number and slash string, it's giving us a normal output. So yeah, this depicts how I handled with buffer overrun. And that's it for homework 1 explanation. Thank you.